Okay, this is from the IPCC report, and it's a graphic showing all the greenhouse gases in the how they're all intermingled. If you notice there's an arrow pointing to H2O in the atmosphere. Okay, water vapor is recognized in the IPCC report as being one of the most significant greenhouse gases. All right, so the thing I want to get across here is the IPCC in one of their graphs recognizes water vapor as a significant greenhouse gas. There's some lower arrows down at the bottom, and they're pointing to where it describes CO2. The IPCC report describes CO2 as a quote-unquote trace gas. Okay? Now, let's take a look at the second chart. Okay, this is a chart from, once again, the IPCC report, and it reviews what's called the global warming potential and the contribution of greenhouse gases. Unfortunately, you can't see it on this chart. I encourage you to go download the IPCC report yourself, but as you can see, it has a bunch of bar charts and a bunch of levels. The one thing you will not see when you download this presentation is water vapor. Somehow they ignore the most significant greenhouse gas out there when they're reviewing the studies and the findings. So once again, in order to make their case, they have to ignore some of the most significant variables out there. This is the most bizarre thing that I found. Okay, now let's say you're going to create a model, and let's say it's going to be about weight loss. If you're going to do a model on weight loss, you would want to go out there and study exercise, caloric intake, and maybe the type of shoes that they're wearing, right? In order to have any good of a solid foundation for a conclusion, you would have to have a clear understanding of each and every one of the most significant variables of the model. Well, in fact, the IPCC doesn't, all right? Because in order to do that, you would have to know the relative contributions of each one of the greenhouse gases. Now, they recognized water vapor as a greenhouse gas, so you would think that they'd understand the contribution that it has. Well, they don't. If you read the IPCC report, you'll see that they don't assign what's called a global warming potential to water vapor. All right? Now, this global warming potential of CO2 is 1, and then all other greenhouse gases are put in relative terms to carbon dioxide. It's called a global warming potential, or a GWP. For the IPCC report, they claim they do not have a global warming potential for water vapor. So how in the world could you ever create a model that has any significance or accuracy at all if you don't even understand the most significant variable? The best example I can give of this is the example of weight loss. Let's say I go out there and I do a study, and I measure all my people, and I measure the type of shoes that they wear. And I totally ignore caloric intake and exercise. Now, more than likely, the people that exercise a lot will be wearing Nikes. People that don't would be wearing dress shoes. So my conclusion would clearly be that wearing Nikes causes you to lose weight. Anyone with an ounce of common sense would know that's absolutely insanity. The type of shoes you wear is insignificant. In fact, if these exercise people wore dress shoes and ran, they would lose weight too. They just would be uncomfortable. But the key here is the type of shoes you wear does not cause you to lose weight. What caused you to lose weight was exercise. Now, if I build a model and totally ignored exercise, I could reach a conclusion and prove to you with my study that the type of shoe you wear causes me to lose weight, but it wouldn't have any validity. That's exactly what they're doing with global warming. They're sitting there and ignoring water vapor, which would be an example of the exercise, and they're focusing on CO2, would be the example of the shoe. In fact, in a real model, what you'd see is you would exercise today and lose weight tomorrow. The exercise would lead the weight loss. So put this in terms of global warming, they would have to show that CO2 increases and then temperature. That's not what happens. What happens is temperature increases first and then CO2. So they've got their model backwards, and that weight loss example is the best example I can give on how backwards this model is. The other important thing is that because runners wear Nikes, every single situation where people lost weight, they would be wearing Nikes, right? But remember, it's the exercise causing the weight loss, not the shoes. It's a bad model if you said the shoes were, and that's exactly what's going on with the CO2, because they know that anytime there's an increase in temperature, CO2 is going to increase also, because growth increases, respiration increases, decomposition increases. CO2 drives the temperature drives the increase in CO2, just as exercise drives the weight loss, but there's also a related variable, shoe type, that you could tie in there, but the shoe doesn't cause it. That's the real problem behind global warming. They've misspecified their model. They're attributing global warming to CO2 when it's really the opposite. The temperature is driving CO2, not the other way around. The problem is, just with the shoe example, in every case of warming, you should see an increase in CO2. And so if you misread the model, you will always prove yourself right, because you're always going to see an increase in temperature and then an increase in CO2. If you reverse those two and just lag it a little bit, you can always prove your case. The point is, though, it's a bad model. Go to any statistics professor and tell them that you have an independent variable that changes after the dependent variable changes. They're going to say you've got a bad model, and that's what's going on here. The other point is you cannot have a significant model that with any validity if you don't understand the most significant variables. The IPCC itself recognizes water vapor as a greenhouse gas, and yet they don't have a global warming potential attributed to it. Now, I was able to do some research and find out what would be an accurate or a relatively good estimate of global warming potential for water vapor, and you can do that because they make claims that water vapor is responsible for X amount of global warming. You know the concentration, so you can back into it. Well, it turns out that the estimates for the global warming potential for water vapor is over 200, meaning that water vapor is not only far greater in concentration in the atmosphere, the potential of it is 200 times that of CO2. So it becomes evident that there's no way, given that kind of a model, you could have any kind of a valid model if you ignore one factor that is 200 times, not only 200 times more potent, but probably about 200 times more prevalent in global warming than CO2. So once again, I ask you, how could you ever reach a scientific consensus if you don't even know the basics of the model?